All right, guys, so test number 4. This is the last test of the first quarter. It's going to be on Friday, November 8th, so we can start reviewing. Number 1, solve the equations in simplest radical form or simplest a plus bi form. Number 1 is a quadratic. You know 3 ways how to solve a quadratic. I'm going to use, I don't know if this is factorable. I don't think it's factorable. I don't feel like dividing everything by 16, so I'm going to go right ahead and start with quadratic formula. So x equals, it's already said equal to 0, so we don't have to worry about that. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And remember, that's all right on your reference sheet, so you don't have to worry about memorizing quadratic formula. So next I'm going to separate it. So 24 divided by 32, right? That comes from 2 times 16 right here, plus or minus the square root of something divided by 32. I type this whole mess into my calculator. That gives me negative 128. And now I simplify the radical. Negative 128, that is negative 64 times 2. So now I have x equals, I'm going to come up here, 24 over 32, plus or minus the square root of negative 64 is 8i. You still have the square root of 2 divided by 32. And then last, I just clean up the fraction. So 24 divided by 32 turns into 3 divided by 4. Plus or minus 8 divided by 32 turns into 1 divided by 4. If you want to put a 1 out here, you can, but you don't have to. And then the I square root of 2 kind of just gets dragged along. For number 2, I cannot do completing the square or quadratic formula because this is not a quadratic. This is x to the third. The only way that I know how to solve this is by factoring it. So to start, I'm going to bring everything to one side. So 4x to the third plus 6x squared. I'm going to subtract the 20x and subtract the 30 equals 0. There is no, if I wanted to, I could take out a 2 actually. If I take out a 2, this is 2x to the third plus 3x squared minus 10x minus 15. Now these 4 terms here, I'm going to split down the middle. I can take out x squared over here. I'm left with 2x plus 3. On the right side, there's a GCF of negative 5. I'm left with 2x plus 3. My parentheses match. So x squared minus 5 times 2x plus 3. And then you still had that GCF of 2 that comes down out front. So I set each piece equal to 0. This is completely factored. So x squared minus 5 equals 0. X squared is equal to 5. X equals, you take the square root. Whenever you take the square root, you have plus and minus. The square root of 5 does not simplify. And then 2x plus 3 equals 0. So x is equal to negative 3 over 2 as well. If you were to take your GCF and set that equal to 0, 2 equals 0 makes no sense. So that kind of just goes away. Number 3, find the curve equidistant to the given point in line. So this is your parabola. Parabola formula is x minus h squared equals 4p y minus k. So this is your focus and the directrix. So always draw this out. So negative 1, 2, 3, 4. 1, 2, 3. That's down here. Y equals 1 is up here. The point that's in the middle of them, this is going 1, 2, 3, 4. So I head back down 2. Right here, that is the vertex. So the vertex is negative 4, negative 1. And then also the p-value, so this is concave down. Concave down because the focus has to be hugged by the parabola. P, you are going down 2, so P is negative 2. When I plug this into the formula, x plus 4 squared equals 4 times P. 4 times negative 2 is negative 8. y minus -1 is y plus 1, and that's your answer. For number 4, write the polynomial equation of least degree that contains the following roots. So x equals -4, x equals 6i, x equals -6i. So this factor is x plus 4. This factor is 6i. This factor is x plus 6i. Always multiply the conjugates together. That way the imaginary number goes away. So this is x plus 4 still. And over here, this is x squared plus 6ix minus 6ix will cancel out. And then you have minus 36i squared. If you remember I squared, that is equal to -1. So negative 36i squared actually turns into positive 36. And then you're going to multiply these out because it says a polynomial equation. So it has to all be multiplied out. This should give you x to the third plus 4x squared plus 36x plus 144. And it wanted f of x for it to be called. So equals f of x for number 4. Number 5, state the domain and range of each function. The domain, this is your x values. Range, this is your y values. So I'm going to take a second now, plug this into my calculator, and I'm just going to draw a quick sketch of what this looks like on the screen. Okay, so number 5, if I type that in, this looks like this. So my domain, because this keeps going up and to the left and up and to the right, my domain is going to be, you can either say from -infinity to infinity, or that's the same thing as all real numbers. Okay, this symbol here we talked about in class. My range, though, is the y value, so how far down to how high up. So if you look, this keeps going up. So the top part, the higher end, it's going to keep going up until infinity. But there is a minimum value right here where it does not go below. So I have to figure out what that point is. So in the calculator, I'm going to press second trace. This is a minimum, so number 3. So left bound, I have to be on the left side of the point. And then right bound on the right side, enter. And I get that this point is 1.25, comma, -5.125. So again, we're talking about the y values, so I'm going to use this here because the range is the y values. So it does include that point because it is not an open circle. So this is -5.125 until infinity for the range. For number 6, my domain, so the x values, this keeps going down and to the left and up and to the right. So my domain, because it keeps going all the way left, all the way right, it's again going to be -infinity until positive infinity, or you could write all real numbers. You do not have to write both. And then my range is actually easier than the last one because this keeps going all the way down and all the way up. And it includes all of the y values in the middle. So every y value is included. So same thing, all real numbers, or if you wanted to write this interval, you could. Symmetry. Numbers 7 and 8, it's the same functions that we were just looking at, and it wants you to find the local mins, maxes, and then the increasing and decreasing intervals in interval notation. And then if there are any decimals, we round them to the nearest thousandth, which is 3 places. So I actually was just working with these two functions a second ago. So we know that number 7 looks like this. And we know what this point is because we had to find it in order to use it for the range. So we already found the min for number 7. That minimum, if you type that into your calculator again, you would do second trace number 3. There's only one min or max for this because again, this is x squared. You can only have one less than. So if you want to pause it and plug it in, feel free. But again, I already talked about how to find that point. That again, second trace. Option 3, a little bit to the left, a little bit to the right, and then enter. It'll give you that point. is 1.250, comma, negative 5.125. So that's for the mins and maxes. There are no maxes in number 7. It's only one min. So now to figure out the increasing and decreasing interval, I'm going to make my number line. This is negative infinity to positive infinity. I have one min and max. So I'm going to put the x value of that min on the number line. So from negative infinity until the min, I'm going down. I am decreasing. And then I hit the min and I start to increase. So once I make my number line, the intervals are super easy from here. So I start off by decreasing. So I'm decreasing from negative infinity until 1.250. And then I change direction and I start to increase from 1.250 until positive infinity for number 7. Number 8, this is an x to the third. So there's an extra min or max that's in here, so it's a little bit more work. So again, this is what this graph looks like. There's one max right here, one min right here. So I am going to press second, trace. I'm going to find the max first. So that's number 4. So I go over to the point. I have to be on the left side of the point. Press enter. To the right side of the point, press enter. Guess, enter. And I get the point that it's negative 1.000, comma 4. So you can write negative 1, comma 4 for that. And then for the min, second trace, number 3. So a little bit to the left, a little bit to the right. Guess, enter. That gives me 0.111, comma 1.942, and then the 3 tells me to stick with the 2 for the rounding part. So that's my max and my min. So now for the increasing and decreasing interval. Again, this is negative infinity, positive infinity. I have 2 extrema, or 2 mins and maxes, so I put them on my number line. I put them in order, so negative 1 is smaller than that positive 0.111. So from negative infinity until negative 1, I am increasing. Then I hit the max and I change direction. Now I'm going down, so I start to decrease. And then from 0.111 until infinity, I am increasing again. So I'm going to take those intervals and put them right into interval notation. So increasing from negative infinity until negative 1. Decreasing from negative 1 until positive 0.111. And then I start increasing again at 0.1 repeating up until infinity. If you see more than one interval, you put a U in the middle. Not as big of a deal, but just know that that is what that means. Numbers 9 and 10, we want the intercepts and a multiplicity statement. So number 9 is actually pretty easy for the intercepts because this is in factored form. So if it's already in factored form, so say x-intercepts or all intercepts? All intercepts. So all intercepts, that includes the x and the y. So let's do one thing at a time. So we have x-intercepts. That is where y equals 0. So f of x, remember, is really y. So 0 equals negative x times x plus 3 times x minus 2 squared. So what I was about to say is that with this being in factored form, it makes it a lot easier for us because we just have to set each of these factors equal to 0 and solve. So negative x equals 0, that gives me x equals 0. Write it as the coordinate 0, comma 0. X plus 3 equals 0. Gives me the root, x equals negative 3. The intercept, though, is negative 3, comma 0. And then on the end, x minus 2 squared equals 0. If you take the square root, you get x minus 2 equals 0. Add the 2 over, so x equals 2 is the root. However, 2 comma 0 is the intercept. Okay, so from here, it wants you to make statements about the multiplicity. So I'm just going to do this kind of underneath. We're going to pretend like this is not here for a second. And then I'll erase this after, but pretend that this is not there. So x equals 0, right, we're going to look at this. So x equals 0. This came from the factor negative x to the first power. So that exponent is a 1. 1 is odd. And if the multiplicity is odd, that means it will cross the x-axis. X equals negative 3 came from the factor x plus 3 to the first. 1 is odd, which means that because the multiplicity is odd, f of x will cross the x-axis at x equals negative 3. And then on the end here, for x equals 2, the multiplicity is even because that exponent is a 2. So even, which means it is tangent to the graph. So this is what your statement should be on your paper. At x equals 0 and x equals negative 3, the multiplicity is odd, so f of x crosses the x-axis at x equals 0 and x equals negative 3. That's one statement. The second part, at x equals 2, the multiplicity is even, so f of x is tangent to the x-axis at x equals 2. Okay, so that's it for multiplicity. We do also have to talk about y-intercepts, though, for this graph. So my y-intercepts are where x equals 0. So y equals negative 0 times 0 plus 3 times 0 minus 2 squared. That gives you y equals 0, but I have to write it as a point, 0, 0 for the y-intercept. Okay, and that's it. That's all it wants. So x-intercepts, y-intercepts, and then the multiplicity. So we did it a little out of order, but that's okay. All right, if you need to pause it because I'm going to erase. That way I have room for number 10. Okay, number 10, a little bit trickier because this is not in factored form. So let's start off by doing the x-intercepts. Again, x-intercepts, that's where y equals 0. So I have 0 equals 8x to the third minus 12x squared minus 18x plus 27. So I'm going to split this down the middle. On the left side, I could take out 4x squared, and I'm left with 2x minus 3. On the other side, I could take out a negative 9, and I'm left with 2x minus 3. Parentheses match, 2x minus 3 times 4x squared minus 9. If I want to, which you should, I'm going to keep factoring 4x squared minus 9 to be 2x minus 3 times 2x plus 3. So this is it completely factored. Now what you might want to do for your multiplicity statements, what might make it easier, you see how you have 2x minus 3's? You can rewrite that as 2x minus 3 squared times 2x plus 3. That'll help with the multiplicity in a second. So now when we go to solve for the intercepts, the x-intercepts, 2x minus 3 equals 0. That gives me x equals 3 over 2. You write it as the coordinate 3 over 2, comma 0. This side, 2x plus 3 equals 0. So x is equal to negative 3 over 2. So that is negative 3 over 2, comma 0. For your multiplicity, at this root here, at x equals 3 over 2, that came from the factor 2x minus 3 squared. 2 is even, so the multiplicity is even, which means that the graph will be tangent to the x-axis. Okay, this, what I have in blue, this does not make up for the whole multiplicity statement. For the other one, we have x equals 3 over 2, negative 3 over 2. That comes from 2x plus 3 to the first. 1 is odd, so the multiplicity is odd. which means it will cross the x-axis. So for what number is this? For number 10, you are going to write at x equals 3 over 2, the multiplicity is even, so f of x is tangent to the x-axis at 3 over 2. The other one. At x equals negative 3 over 2, the multiplicity is odd, so f of x crosses the x-axis at negative 3 over 2. And now for the y-intercepts. Last part. So again, y-intercepts, that's where x equals 0. So for this one, I have y equals 8 times 0 to the third minus 12 times 0 squared minus 18 times 0, and then plus 27. So that gives me y equals 27. That coordinate, though, because intercepts I have to write as coordinates, is 0, 27. Okay? Numbers 11 and 12, algebraically determine whether the functions are even, odd, or neither, and state what this means for the graph. So even, odd, or neither, that's when you plug in negative x. So for number 9, when I plug in negative x, I get 3 times negative x to the fourth minus 2 times negative x squared plus 10. So negative x to the fourth, the negative ends up canceling out, so this is 3x to the fourth. Negative x squared becomes positive x squared, so this is also negative 2x squared. Then you still have the plus 10 on the end. So if everything is equal, it is even. If everything is opposite, it is odd. If it's neither, then it's neither. So 3x to the fourth, 3x to the fourth, those are the same. Negative 2x squared, negative 2x squared, those are the same. Plus 10, also the same. Everything is equal. This function is even. The second part is to state what this means for the graph. So if a function is even, there is line symmetry about the y-axis. That's for number 9. For number 10, same deal. You're going to plug in negative x, see what the result is. So f of negative x, negative 2 times negative x to the fifth, plus 4 times negative x to the third, minus 2 times negative x. So negative x to the fifth is negative x to the fifth. The negative does not cancel out. So negative 2 times negative x to the fifth is going to be a positive 2x to the fifth. Negative x to the third ends up being negative x to the third. So 4 times negative x to the third, negative 4x to the third. And negative 2 times negative x is a positive 2x. So negative 2x to the fifth, positive 2x to the fifth. Positive 4x to the third, negative 4x to the third. Negative 2x, positive 2x. This function is odd. There is rotational symmetry of 180 degrees. All right? If you plug in negative x and you don't know how to simplify it, this is where you can cheat a little bit. So you still have to do all of this stuff that I have written down. But let's say you don't know what it means. So you can plug in negative 5, positive 5, see what happens. Okay? But again, that's the cheat to it. And then 13 and 14, determine the end behavior algebraically. So don't use your calculator for this. This you need to figure out what the first term would be if you multiplied everything out. So here, if I were to multiply everything out, this would be negative x squared, this would be x, and this would be x. If I multiply all of these out, I get negative x to the fourth power. My leading coefficient would be negative 1, and the degree would be 4. So because the degree is even, they go in the same direction, and because the leading coefficient is negative, they both go down. So my end behavior, this always starts off the same. As x approaches negative infinity, f of x approaches, and then you fill in the blank, Same thing for the second half. As x approaches positive infinity, f of x approaches. So they're both going down. They both go down to negative infinity. For number 14, this first term would be x. If I multiply this, my first term would be 9x squared. So if I multiply the two of them together, then the first term would be 9x to the third. So my leading coefficient would be a 9, and the degree would be a 3. Because my degree is 3, they go in opposite directions. Because the leading coefficient is positive, they make a positive slope. So, again, the beginning is the same. As x approaches negative infinity, f of x approaches. And as x approaches positive infinity, f of x approaches. So as x approaches negative infinity, as it goes to the left, my arrow is pointed down. So it goes down to negative infinity. As x approaches positive infinity, as it goes to the right, my arrow is pointed up towards positive infinity. And then my last two questions are my word problems. So number 15, Jennifer hit a softball up in the air. Its height in feet is represented by that function. Find the vertex form of the path of the softball, then find the maximum height reached. So first of all, this is my softball, right? It goes up and then it comes down. So this is why we have a negative parabola, a negative quadratic. So first question is to find the vertex form. So I'm going to switch sides. So negative 4x squared plus 72x plus 3 equals y. Because again, I want it to look like this. This is vertex form. So I'm going to put my x's on the left. So first I'm going to divide everything. Actually, you know what? First I'm going to subtract the 3 over. So negative 4x squared plus 72x equals y minus 3. Now I'm going to divide everything by negative 4. So this is x squared minus 18x equals negative 1 over 4, right? 1 divided by negative 4 is negative 1/4. Y plus 3 over 4. So now I can go into completing the square. So half it, square it. So negative 9 squared is plus 81. Plus 81, and now add it back. So this is negative 1 over 4y, and then 3 over 4 plus 81 is 327 over 4. You can do that right in the calculator. And then my last step, again, I need to factor out this 4p value. So I'm going to divide by negative 1 over 4. Do that right in the calculator. Make sure you put parentheses in. The biggest problem on your last test was that you did not put parentheses when you were dividing by a fraction. So vertex form is x minus 9 squared equals negative 1 over 4 times y. This is a 4, not a y. Y minus 327. So what this means, x, it doesn't tell you. So it just says it's height in feet. So x and y are both in feet. So if this is my parabola, the maximum here is 9, 327. It wants the maximum height. That's the y value. So your answer is 327 feet for the second part. For the second word problem, the trajectory of a bullet fired by a gun can be modeled by that equation. X and y are measured in feet. So again, this is the bullet. It goes over and around. So x is the horizontal distance and y is the vertical distance. Find the vertex form of the path of the bullet. So we're going to do exactly what we just did before. So negative x squared plus 10x plus 83 equals y. I'm going to subtract the 83 over first equals y minus 83. Now I divide by negative 1. So this is now x squared minus 10x equals negative y plus 83. So now I can go into completing the square. So half it, square it, and then add it back. So x minus 5 squared equals negative y, and then 83 and 25 give me 108, so plus 108. Last step, I'm going to factor out the p-value, or the 4p value, which is going to be negative 1. So negative 1 times y minus 108. Okay? Second question, algebraically determine how far the bullet will travel before it hits the ground. So how far it'll travel, that's this way, how far it goes. That's your x value. Whenever you're solving for an x value, you have to plug something in for y. So what is your y value before it hits the ground? You're hitting the ground. The y value on the ground, right, y value is the vertical distance, is 0. So you have to figure out what the x value is. So I'm just going to plug it into this. So x minus 5 squared equals negative 1 times 0 minus 108. So that gives me x minus 5 squared equals 108. I take the square root of both sides. X minus 5 equals plus and minus the square root of 108. Doesn't matter if I simplify because this says round to the nearest thousandth, so it wants it to be in a decimal form anyway. So I get x equals 5 plus and minus the square root of 108. If I typed into my calculator 5 minus the square root of 108, that gives me negative 5.392. If I type in 5 plus the square root of 108, that tells me that it is 15.392. We're not going to do a negative distance, right? Because it has to come here. Time starts though, the bullet already has a little bit of height to it. So this answer gets rejected, and my answer to the second part of 16 is 15.392 feet before it hits the ground. All right? If you have any questions, let me know. Happy studying, guys.